Hello viewers, in today's class we are going to discuss one important application of Rolle's theorem, right? So in our earlier videos we have already discussed plenty of examples related to the application of Lagrange's mean value theorem, right? So in this lecture we'll see uh, the important application of Rolle's theorem regarding the roots of an equation, right? So here we have a problem in which we have to prove that between any two roots of this equation, that is e raised to x times cosine x is equal to 1, there exists at least one root of this equation, right? So here we'll show that between any two roots of this equation there is at least one root of this equation, right? And we'll see how Rolle's theorem can help us to find the solution of this problem. So before taking this problem, let us quickly revisit the statement of Rolle's theorem, right? So Rolle's theorem says that if we have a function, say y is equal to f of x, and this function is defined in some interval, say a comma b, and if this function satisfies three conditions, right? So the conditions are the first one is that this function f of x should be continuous in the interval that is the closed interval a comma b, right? And the second condition is that this function f of x should have a derivative, right? So this function should have a derivative at each point in the open interval a comma b, right? And moreover, the value of the function at this point a and this point b, that is the endpoints, f of a should be equal to f of b, right? So if a function y is equal to f of x, which is defined in some closed interval a comma b, and it satisfies these three conditions: f of x is a continuous function in the closed interval a comma b, f of x is differentiable or has a derivative in the open interval a comma b, and the value of the function at a and b are equal, then Rolle's theorem says that there must exist some point, say x is equal to c, which belongs to this interval a comma b, that is c lies between a and b, such that f prime of c is equal to 0, right? So it implies that the derivative of this function must vanish at x is equal to c, right? Or in other words, we can say that the slope of the tangent at this point c should be equal to 0, right? Or the tangent is parallel to x-axis, right? So this is the statement of Rolle's theorem, and we'll apply these conditions to this problem, and we'll see how we can solve this given problem. So here we have to prove that between any two roots of this equation, right? So here we are given the equation that is e raised to x cos x is equal to 1, right? And between any two roots of this equation. So let us assume that we have two roots alpha and beta are the roots of this equation, right? So we assume that alpha and beta are the two roots of this equation. Now, since alpha and beta are the roots of equation 1, then these values must satisfy this equation, right? So x is equal to alpha and x is equal to beta should satisfy this equation. So we have e raised to alpha cos of alpha is equal to 1, and e raised to beta cos of beta is equal to 1, right? So we have these two equations, right? So now here comes the role of Rolle's theorem, right? So for applying the Rolle's theorem to this problem, let us define an appropriate function, right? Because we need a function y is equal to f of x. So to define this function, we'll take help of this equation, right? Now see, if we write this equation as cos x is equal to 1 over e raised to x, which can be written as e raised to minus x, and if we take cos x to this side, we have e raised to x minus cos x is equal to 0, right? Then this left hand part of this equation may be treated as our function f of x, right? So we can here define the function f of x is equal to e raised to minus x minus cos x, right? So now we have defined this function, and now we need to define this interval, right? So what we will do, we'll take the interval as x belonging to the closed interval alpha comma beta, right? So we'll use these two roots as the endpoints of the interval, right? So we have defined f of x using this equation, and then we have the interval that is for all x belonging to this interval alpha comma beta, right? So now let us apply the conditions of Rolle's theorem to this function, right? So the first condition is that f of x should be continuous, right? And here we see that f of x is a combination of exponential function and the trigonometric function, right? And we know that the exponential function and the trigonometric function both are continuous functions. So f of x is a difference of two continuous functions, right? E raised to minus x and cosine x. So f of x is the difference of two continuous functions. So we can claim that the difference of two continuous functions is again a continuous function, right? So f of x is continuous in the interval alpha comma beta, right? Now let us see the second condition. So now let us find out the derivative of f of x, that is f prime of x. So the derivative of e raised to minus x is negative of e raised to minus x, and the derivative of cosine x is negative sine x. So this negative and negative sine x becomes positive sine x, right? And from this expression we can again see that the derivative of e raised to minus x, it exists at all points in the interval alpha comma beta, and similarly the derivative exists for this sine x, that is sine x is defined in the interval alpha comma beta, right? So these two functions e raised to minus x and sine x both are defined in this interval alpha comma beta. So we can claim that the derivative, it exists in this interval that is x belonging to alpha comma beta. So f of x has a derivative at each point in this interval, right? Now let us take the third condition, right? So here f of a should be equal to f of b. So here we have alpha and beta, right? Now see, what is f of alpha? So f of alpha can be obtained from here. So we have e raised to minus alpha minus cos of alpha, right? And what is f of beta? F of beta is e raised to minus beta minus cos of beta, right? Now if we see equation number 2 and 3, we can write from here cos alpha is equal to 1 over e raised to alpha, which is e raised to minus alpha. And if we take cos alpha to this side, we have e raised to minus alpha minus cos of alpha is equal to 0, right? So this quantity is equal to 0, right? And similar is the case with this equation. So we have from here we can write cos of beta is equal to 1 over e raised to beta, which is equal to e raised to minus beta. So taking cos beta to this side, we have e raised to minus beta minus cos of beta is equal to 0, right? So this quantity is also equal to 0. So we can now see that f of alpha is equal to f of beta, right? And both the quantities are equal to 0. So we can see that all the conditions of Rolle's theorem are satisfied by this function in the interval that is alpha comma beta, right? So there must exist some point x is equal to c belonging to the interval alpha comma beta such that f prime of c should be equal to 0, right? So now we have some point x is equal to c which belongs to this interval alpha comma beta, this interval alpha comma beta such that c lies between alpha and beta, and f prime of c should be equal to 0, right? So here the derivative at x is equal to c must disappear, right? Now see uh, the expression for f prime of x is equal to minus e raised to minus x plus sine x, right? So we can substitute x is equal to c in this equation, right? So f prime of c is equal to 0. So f prime of c is now equal to minus e raised to minus c plus sine of c is equal to 0, right? So because f prime of c is equal to minus e raised to minus c plus sine of c, right? So now we have this equation, right? So minus e raised to minus c plus sine c is equal to 0. Now if we take this term to the right hand side, we have sine c is equal to e raised to minus c, right? So we can now write sine c is equal to 1 over e raised to c, right? And if we multiply e raised to c to this term sine c, we have e raised to c sine c, and that is equal to 1. So this is e raised to c sine of c, and taking 1 to the left hand side, we have minus 1 is equal to 0, right? So this is this equation suggests that if we replace x by c in this equation, we'll get this equation, right? And this equation suggests that x is equal to c is a root of this equation, right? Because if we replace x by c, we'll get e raised to c sine c minus 1 is equal to 0, which is this equation, right? So viewers, this is how by making use of the statement or the concept of Rolle's theorem, we can solve these type of problems related to the roots of equations.